Introduction to LAN topologies. In this video, we are going to see about LAN topologies.
A network is a set of devices interconnected by a communication medium. Each device is referred to as a node. A node can be a computer, printer, or any other computing device. The manner in which nodes are geometrically arranged and connected is known as a topology of the network. Physical topology of a local area network should have the following desirable features. The topology should be flexible to accommodate changes in physical locations of the stations, increase in the number of stations, and increase in the LAN geographic coverage. The cost of physical media and installation should be minimum. The network should not have any single point of complete failures. Types of topologies in network: bus topology, ring topology, star topology, mesh topology. Bus topology. In this video, we are going to learn about bus topology. Bus topology, also called horizontal topology. In bus topology, multiple devices are connected one by one by means of a single cable. Bus is passive topology because it requires termination. The central cable is the backbone of this network and is known as a bus. When one computer sends a signal up the wire, all the computers on the network receive the information, but only one accepts the information, the rest discard the messages. Advantages: easy to use and easy to install. Needs fewer physical connectivity devices. A repeater can also be used to extend a bus topology network. Low cost. Disadvantages: heavy network traffic can slow a bus considerably. It is difficult to troubleshoot a bus. Failure of a cable affects all devices on the network. Difficult to add new node. Star topology. In this video, we are going to learn about star topology. A star topology consists of a number of devices connected by point-to-point links into a central hub. In star topology, every node, that is computer workstation or any other peripheral, is connected to a central node called a hub or switch. A star network consists of one central switch, hub or router, which acts as a conduit to transmit messages. All peripheral nodes may thus communicate with all others by transmitting to and receiving from the central node only. Advantages: it is easy to modify and add new nodes to a star network without disturbing the rest of the network. Centralization allows the inspection of traffic through the network. Easy to detect faults and to remove parts. Installation and configuration is easy. Failures of any node do not bring down the whole star network. Disadvantages: If the central hub fails, the whole network fails to operate. Each device requires its own cable segment. Requires a large amount of cable to be connected. Token ring topology. In this video, we are going to learn about token ring topology. In a ring topology, each computer is connected to the next computer with the last one connected to the first. Data travel from node to node, with each node along the way handling every packet. The signals travel on the cable in only one direction. Each computer retransmits what it receives. Because a ring topology provides only one pathway between any two nodes, ring networks may be disrupted by the failure of a single link. Ring is an active network. In this, termination is not required. Advantages: cable failures are easily found. Performs better than a bus topology under heavy network load. Does not require a central node to manage the connectivity between the computers. It is quite easy to install and reconfigure, since adding or removing a device requires moving just two connections. Disadvantages: adding or removing nodes disrupts the network. It is difficult to troubleshoot a ring network. Failure of one node on the ring can affect the whole network. Cost of cable is more in ring network.
LAN protocol. In this video, we are going to see about LAN protocol. Data networks are a combination of software and hardware components. The hardware includes transmission media, devices, and transmission equipments. The software allows the hardware to interact with one another and provides access to the network. The application programs that use the network do not interact with the hardware directly. The application programs interact with the protocol software, which follows the rules of the protocol while communicating. Protocol is a network term used to indicate the set of rules used by a network for communication. All the computers connected to the network use the protocol software. The International Standards Organization, that is ISO, has developed a 7-layer reference model for data networks, known as Open System Interconnection, that is OSI model. The OSI model specifies the functions of each layer. It does not specify how the protocol needs to be implemented. The 7 layers of the OSI model are: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. Each layer at a sender's side transforms the data according to the function it handles. For this, it attaches headers to the data. At the receiving side, the corresponding layer applies the inverse of the transformation and has been applied to at the source. As an example, if the data link layer at the sender side adds an error detection code to the frame, then at the receiver side the data link layer verifies the error detection code and removes it from the frame before passing it to the next higher level, that is the network layer. The 7-layer ISO reference model forms a framework for communication between devices attached to the network. For example, the TCP/IP protocol is organized into 5 layers. The X.25 Wide Area Network Protocol, the first public data network, provides connectivity to public switch-to-telephone network, that is PSTN network, and has 3 layers. IEEE 802 standards. In this video, we are going to see about IEEE 802 standards. IEEE 802 standards. The IEEE Local Network Standards Committee has developed a series of standards for local area networks. These standards have been produced with reference to the ISO model for OSI, and they are summarized here. General Management, Addressing, and Internetworking. IEEE 802.1 Part A Overview and Architecture. IEEE 802.1 Part B Addressing, Internetworking, and Network Management. Logical Link Control. IEEE 802.2 Logical Link Control, that is LLC, employed in conjunction with the 4 media access standards defined under IEEE 802.3, 802.4, 802.5, and 802.6. Media Access Control. IEEE 802.3 Carrier Sense Multiple Access and Collision Detection, that is CSMA-CD Access Method and Physical Layer Specifications. Note: the European Computer Manufacturers Association, that is ECMA, has produced a set of standards which bears a close relationship to that of IEEE 802.3. ECMA standards 80, 81, and 82 relate to CSMA-CD baseband LAN coaxial cables, physical layer, and link layer respectively. IEEE 802.4 Token Passing Bus Access Method and Physical Layer Specifications. IEEE 802.5 Token Passing Ring Access Method and Physical Layer Specifications. IEEE 802.6 Metropolitan Network Access Method and Physical Layer Specifications. Standard Ethernet. In this video, we are going to see about Standard Ethernet. Standard Ethernet. We refer to the original Ethernet technology with a data rate of 10 Mbps as a Standard Ethernet. Although most implementations have moved to other technologies in the Ethernet evolution, there are some features of the Standard Ethernet that have not changed during the evolution. The Ethernet frame contains 7 fields: Preamble, Start Frame Delimiter, that is SFD, Destination Address DA, Source Address SA, Type, Data, CRC. Implementation of Standard Ethernet. Standard Ethernet uses a coaxial cable, that is bus topology, or a set of twisted pair cables with a hub, that is star topology. We need to note that transmission in the standard Ethernet is always broadcast, no matter if the intention is unicast, multicast, or broadcast. Efficiency of standard Ethernet. The efficiency of the Ethernet is defined as the ratio of the time used by a station to send the data to the time the medium is occupied by this station. The practical efficiency of standard Ethernet has been measured to be efficiency is equal to 1 by 1 plus 6.4 into A. Fast Ethernet. In this video, we are going to see about Fast Ethernet. Fast Ethernet. If one were to design a high speed, that is 100 Mbps or more, LAN from scratch, one would not choose CSMA CD as the basis for their design. CSMA CD is simple to implement and robust in the face of faults. However, it does not scale well. As the load on a bus increases, the number of collisions increases, degrading performance. Furthermore, as the data rate for a given system increases, performance also decreases. The reason for this is that at a higher data rate, a station can transmit more bits before it recognizes a collision, and therefore more wasted bits are transmitted. These problems can be overcome. To accommodate higher loads, a system can be designed to have a number of different segments interconnected with hubs. The hubs can act as barriers separating the LAN into collision domains, so that a collision in one domain does not spread to other domains. The use of switched Ethernet hubs in effect eliminates collisions, further increasing efficiency. Despite some drawbacks to its use, Ethernet-style LANs have been developed that operate at 100 Mbps, 1 Gbps and 10 Gbps. Fast Ethernet refers to a set of specifications developed by the IEEE 802.3 committee to provide a low-cost Ethernet-compatible LAN operating at 100 Mbps. The blanket designation for these standards is 100 base T. All of the 100 base T options use the IEEE 802.3 MAC protocol and frame format. 100 base X refers to a set of options that use the physical medium specifications. All of the 100 base X schemes use two physical links between nodes, one for transmission and one for reception. 100 base TX makes use of shielded twisted pair, that is STP, or high quality unshielded twisted pair, that is UTP. 100 base FX uses optical fiber. To achieve the 100 Mbps data rate over lower quality cable, 100 base T4 dictates the use of 4 twisted pair lines between nodes with the data transmission, making use of 3 pairs in one direction at a time. For all of the 100 base T options, the topology is similar to that of 10 base T, namely a star-wire topology. A traditional Ethernet is half-duplex. A station can either transmit or receive a frame, but it cannot do both simultaneously. With full duplex operation, a station can transmit and receive simultaneously. If 100 Mbps Ethernet ran in full duplex mode, the theoretical transfer rate becomes 200 Mbps. The attached stations must have full duplex rather than half duplex adapter cards. The central point is a switch. In this case, each station constitutes a separate collision domain. In fact, there are no collisions and the CSMA-CD algorithm is no longer needed. However, the same 802.3 MAC frame format is used and the attached stations can continue to execute the CSMA-CD algorithm even though no collision can ever be detected. Gigabit Ethernet. In this video, we are going to see about Gigabit Ethernet. The strategy for Gigabit Ethernet is the same as that for Fast Ethernet. While defining a new medium and transmission specification, Gigabit Ethernet retains the CSMA-CD protocol and frame format of its 10 Mbps and 100 Mbps predecessors. It's compatible with 100 base T and 10 base T, preserving a smooth migration path. As more organizations move to 100 base T, putting huge traffic loads on backbone network, demand for Gigabit Ethernet has intensified. A 1 Gbps LAN switch provides backbone connectivity for central servers and high-speed workgroup switches. Each workgroup LAN switch supports 1 Gbps links to connect to the backbone LAN switch and to support high-performance workgroup servers, and 100 Mbps links to support high-performance workstations, servers, and 100 Mbps LAN switches. The current 1 Gbps specification for IEEE 802.3 includes the following physical layer alternatives: 1000 base LX. This long wavelength option supports duplex links of up to 550 meter of 62.5 micrometer or 50 meter multi-mode fiber, or up to 5 kilometer of 10 micrometer single mode fiber. Wavelengths are in the range of 1270 to 1355 nanometer. 1000 base SX. This short wavelength option supports duplex links of up to 275 meter using 62.5 micrometer multimode, or up to 550 meter using 50 micrometer multimode fiber. Wavelengths are in the range of 770 to 860 nanometer. 1000 base CX. This option supports 1 Gbps links among devices located within a single room or equipment rack using copper jumpers, specialized shielded twisted pair cable that spans no more than 25 meter. Each link is composed of a separate shielded twisted pair running in each direction. 1000 base T. This option makes use of 4 pairs of category 5 unshielded twisted pair to support devices over a range of up to 100 meter. Token ring IEEE 802.5. In this video, we are going to see about token ring IEEE 802.5. Token ring IEEE 802.5. In a token ring, a special bit pattern called the token circulates around the ring whenever all stations are idle. When a station transmits, it breaks the ring and inserts its own frame with destination and source addresses. When the frame eventually returns to the originating station after completing the round, the station removes the frame and closes the ring. Because there is only one token, only one station can transmit at a given instant, thus solving the channel access problem. Features. It uses a point-to-point connect. Throughput and efficiency at high load are excellent. Token ring supports short frames. Each station is connected to the ring through a ring interface unit, that is RIU. The sequence of token is determined by the physical locations of the stations on the ring. IEEE 802.5 cable standards. The token ring standard IEEE 802.5 specifies two types of transmission medium discussed below. Shielded twisted pair, that is STP. Unshielded twisted pair, that is UTP. IEEE 802.5 MAC sublayer protocol. The IEEE 802.5 token protocol consists of following fields. Start delimiter, that is SD. Start delimiter field marks the beginning of the frame. It is 1 octet long unique bit pattern. Access control, that is AC. It is 1 octet long field containing priority bits P, token bit T, monitoring bit M, and reservation bits R. Frame control, that is FC. It is 1 octet long field and indicates the type of frame data frame or control frame. It also distinguishes the control frames. Destination address DA. The destination address field is 2 or 6 octets long. Source address SA. The source address field is also 2 or 6 octets long. Data field data. It can have a 0 or more octets. There is no maximum size, but the frame transmission time is limited by the token holder timer. Frame check sequence FCS. The frame check sequence is 4 octets long and contains the CRC code. It checks on DA, SA, FC, and data fields. End delimiter ED. It is 1 octet long and contains a unique bit pattern marking the end of a token or data frame. Frame status FS. This field is 1 octet long and contains a unique bit pattern marking the end of a token or data frame. Token bus performance. When the traffic is light, the token will spend most of its time idly circulating around the ring. When traffic is heavy, there is a queue at each station. The network efficiency can approach 100% under conditions of heavy load. Timing jitter. On a ring transmission medium, clocking is included with the signal. This clock recovery serves two purposes: to know when to sample the incoming signal, for transmitting the signal to next repeater. This clock recovery deviates randomly from the mid-bit transitions of the received signal. Few reasons for the clock deviation are: noise during transmission, imperfections in the receiver circuitry, delay distortions. This deviation of clock recovery is known as timing jitter. FDDI. In this video, we are going to learn about FDDI. FDDI. FDDI, Fiber Distributed Data Interface, is a set of ANSI and ISO standards for data transmission on fiber optic lines in a local area network LAN that can extend in range up to 200 km, that is 124 miles. The FDDI protocol is based on the token ring protocol. In addition to being large geographically, an FDDI local area network can support thousands of users. FDDI is frequently used on the backbone for a wide area network WAN. Features of FDDI: number of stations, up to 1000 connections are allowed, 500 and connected stations. Total fiber path, up to 200 km of total fiber length is allowed. Typical parameters of transmission medium are: optical source 1300 nm LED, core diameter 62.5 micron, cladding diameter 125 micron, numerical aperture 0.275, bandwidth 500 MHz per kilometer. Advantages: high bandwidth, security, use of multiple tokens, system fault tolerance. Disadvantages: FDDI is a complex technology. FDDI is costly. Wireless local area network, that is wireless LAN. In this video, we are going to see wireless local area network, that is wireless LAN. A wireless LAN is a wireless local area network that provides wireless network communication over short distances using radio or infrared signals instead of traditional network cabling. A wireless LAN typically extends an existing wired local area network. Wireless LANs are built by attaching a device called the access point, that is AP, to the edge of the wired network. Clients communicate with the AP using a wireless network adapter similar in function to a traditional Ethernet adapter. The most popular wireless LAN are Wi-Fi, broadband, modems, etc. Wi-Fi. Wi-Fi is a type of wireless networking protocol that allows devices to communicate without cords or cables. Wi-Fi is technically an industrial term that represents a type of wireless local area network, that is LAN protocol, based on the 802.11 IEEE network standard. It is the most popular means of communicating data wirelessly within a fixed location. Wi-Fi is increasingly becoming the preferred mode of internet connection all over the world. To access this type of connection, one must have a wireless adapter on their computer. Wi-Fi provides wireless connectivity by emitting frequencies between 2.4 GHz to 5 GHz based on the amount of data on the network.
Areas which are enabled with Wi-Fi connectivity are known as hotspots. To start a wireless connection, it is important that the wireless router is plugged into the internet connection and that all the required settings are properly installed. Broadband. The term broadband refers to the wide characteristics of a transmission medium, and it has an ability to transport multiple signals and traffic simultaneously. The major types of broadband available in India include DSL, digital subscriber line, cable, satellite, fiber optic and mobile broadband. Broadband allows users to take advantage of technologies including video conferencing, voice calls over computers, and streaming high-quality audio and video. Examples of available providers: BSNL, etc. Repeater. In this video, we are going to learn about repeater. A repeater is an electronic device that simply regenerates the signal. Dual wireless amplifiers, dual low noise amplifiers, dual external high gain antennas. Repeater receives a signal before it becomes too weak or corrupted and regenerates the original bit pattern and sends the refreshed signals. Repeaters are used to amplify signal, and it is actually a signal regenerator. A digital device that amplifies, reshapes, retimes, or performs a combination of any of these functions on a digital input signal for retransmission. Repeaters are used in offices and large homes. In office, repeater is installed between two segments of LAN and acts as a two-port node. A repeater placed on the line before the legibility of the signal becomes lost. The repeater extends the length of the LAN segment, provide the long-distance communication. In home or office network, internet connection will extend only small area with modem. A repeater that receives a signal and retransmits it at a higher level or higher power or onto the other side of an obstruction so that the signal can cover longer distances. Usage. Repeaters are used to increase the range of a transmitted signal by retransmission. An optical communication repeater receives light as input and outputs light. The output signal power source is external to the input power, but the output power may be driven by input power. Radio repeaters are used in radio communication services such as commercial or amateur video. A radio repeater consists of a radio receiver connected to a transmitter. The radio signal is received, amplified, and retransmitted usually on a different frequency. Higher radio frequencies are limited to line-of-sight transmission. Their range is blocked by mountains and the curvature of the earth, So, repeaters are located on hills and mountains to retransmit the signal beyond the obstruction. Radio repeaters are also extensively used in broadcasting. Repeaters can be classified into two categories: local repeater, remote repeater. Local repeater. Local repeaters are used to connect LAN segments separated by a very small distance. Remote repeater. Remote repeaters are used to connect LAN segments that are far from each other. A transmission line known as a link segment is provided between two remote repeaters. Applications. Repeaters are used in radio communication, subways and tunnels, vehicles. Radio communication. Radio repeaters are used in radio communication services such as commercial radio. Higher radio frequencies are limited to line-of-sight transmission. Their range is blocked by mountains and the curvature of the earth. So, repeaters are located on hills and mountains to retransmit the signal beyond the obstruction. Subways and tunnels. In tunnels, donor antennas are located on both the ends of the tunnel. Signals received from the BTS are amplified and then projected into the tunnel through the service antenna, providing coverage to the length of the tunnel. Vehicles. The basic setup of a cell phone repeater is to have an external antenna placed in the area which has good signal. The internal antenna takes the repeated signal and broadcasts it to the area which is not receiving cell phone signal. Advantage. Makes it easy to expand a network over a large distance. Connection between various types of media, for example, fiber optic, UTF, coaxial cable, is possible. Traffic cannot be filtered to ease congestion. A repeater cannot work across multiple network architectures. Disadvantage. A repeater cannot work across multiple network architectures. Bridges. In this video, we are going to learn about bridges. A bridge is a connecting server which connects two or more local area networks together. Bridges reduce the amount of traffic on a local area network LAN by dividing it into two segments. Bridges are relatively simple and efficient traffic regulators. However, in most networks, they have been replaced by hubs, switches, and routers. Bridges operate at the data link layer, that is layer 2 of the OSI model. Bridges inspect incoming traffic and decide whether to forward or discard it. Bridges serve a similar function as network switches that also operate at layer 2. Traditional bridges, though, support one network boundary, that is, accessible through a hardware port, whereas switches usually offer 4 or more hardware ports. Switches are sometimes called multi-port bridges for this reason. Types of bridges. There are 3 types of network bridging technologies: transparent bridging, translational bridging, source root bridging. Transparent bridging. The simplest type of bridge is the transparent basic bridge. It stores the traffic until it can transmit it to the next network. The amount of time the data is stored is very brief. Traffic is sent to all ports except the port from which the bridge received the data. No conversion of traffic is performed by a bridge. In this type, the bridge is similar to a repeater. A transparent bridge is invisible to the other devices on the network. Transparent bridges perform only the function of blocking or forwarding data based on the MAC address. The devices on the network are oblivious to these bridges' existence. Transparent bridges are by far the most popular types of bridges. Translational bridging. A translational bridge can convert from one networking system to another. Translational bridges are useful for connecting two different networks such as Ethernet and token ring networks. Depending on the direction of travel, a translational bridge can add or remove information and fields from the frame as needed. Source root bridging. Source root bridges were designed by IBM for use on token ring networks. The source root bridge derives its name from the fact that the entire root of the frame is embedded within the frame. This allows the bridge to make specific decisions about how the frame should be forwarded through the network. The diminishing popularity of token ring makes the chance to work with the source root bridge, which is very low.
Switching hubs. In this video, we are going to see about switching hubs. A switch which resembles a hub is known as switching hub, but there is a stark difference between hub and switching hub or a switch. Hub acts as a concentrator and repeater. It consists of a single box with multiple ports. Each port is connected with a separate computer. A signal transmitted by a computer travels to all ports like a bus topology. With the evolution of bridge technology, a data packet input to one port is first checked for its destination and is outputted accordingly to the respective port. In this manner, multiple ports can communicate simultaneously with one another using switch. The switching hub interprets the MAC address of the destination computer contained in the data packet and sends the data packet to the appropriate destination computer using the appropriate port when hub uses the technique of a repeater in doing so. Therefore, switching hub is treated as a bridge.
Routers. In this video, we are going to learn about routers. Routers are devices whose primary purpose is to connect two or more networks and to filter network signals so that only desired information travels between them. Routers operate primarily by examining incoming data for its network routing and transport information. When a data packet comes in one of the lines, the router reads the address information in the packet to determine its ultimate destination. Routers perform the traffic directing functions on the Internet. A data packet is typically forwarded from one router to another through the networks that constitute the internetwork until it reaches its destination node. The most familiar type of routers are home and small office routers that simply pass data such as web pages, email, IM, and videos between the home computers and the Internet. An example of a router would be the owner's cable or DSL modem, which connects to the Internet through an ISP.
Virtual LAN, that is VLAN. In this video, we are going to see about virtual LAN, that is VLAN. Virtual LAN is software that is employed to provide multiple networks in single hub by grouping terminals connected to switching hubs. It is LANs that is grouped together by logical addresses into a virtual LAN instead of a physical LAN through a switch. The switch can support many virtual LANs that operate with having different network addresses or as subnets. Users within a virtual LAN are grouped either by IP addresses or by port address, with each node attached to the switch via a dedicated circuit. Users can also be assigned to more than one virtual LAN. A router is generally required to establish communication between VLANs. Characteristic of VLAN. Workstations can be provided with full bandwidth at each port. Relocation of terminals becomes easy.